Yes, we are going to discuss part 2 of 2.6. We did work out one of these problems, number 7. Number 8, evaluate integral 1 over a square plus x square dx. If it is a plus sum of two squares, the transformation must be x is equal to a tan theta. So x is equal to a tan theta. Therefore, dx is equal to a secant square theta, and a square plus x square is you have an a square plus x square here. So a square plus x square is a square plus a square tan square theta. That is a square times 1 plus tan square theta. 1 plus tan square theta is secant square theta. So that is a square plus x square is equal to a square secant square theta. Therefore, this integral is equal to 1 over 1 plus a square plus x square dx is equal to a secant square theta divided by a square secant square theta. What secant square theta cancels, 1a cancels, you get a 1 over a, and that is 1 over a times theta. And now what is theta? X is a tan theta. So d theta is x over a. So theta is tan inverse x over a. So the answer is 1 over a tan inverse x over a. 1 over a tan inverse x over a. So that is the antiderivative of 1 over a square plus x square. So you have two important results here. One square antiderivative of 1 over a square minus x square dx is sine inverse x over a. 1 over a square plus x square dx is 1 over a tan inverse x over a. See the difference? In the case of sine inverse, there is no 1 over a. Or in the case of tan inverse, there is a 1 over a tan inverse x over a. So these are two important, very important standard results. Okay, now let us start with this is question number 22 in the book. Question number 22 in the book. Differentiate y is equal to tan inverse x square. So you use the formula for tan inverse x and then chain rule. Dy over dx is 1 over 1 plus x square square, because you recall the formula tan inverse x derivative is 1 over 1 plus x square. Here it is tan inverse x square, so it must be the square of x square. 1 over 1 plus tan 1 plus x square square times, now differentiate x square, derivative is 2x. And so the final answer is 2x divided by 1 plus x to the 4. That's it. It's application of chain rule. Then 24. Gx is equal to cos inverse square root of x. And so g prime x is equal to negative 1 over square root of 1 minus square root of x square. So formula for cos inverse x is negative 1 over square root of 1 minus x square. So in this case it is square root of x. So negative 1 over square root of 1 minus square root of x the whole square. Multiply that by the derivative of square root of x. So that times 1 over 2 times square root of x, or simply negative 1 over 2x times square root of 1 minus x square. Number 26. Rt is equal to sine inverse 1 over t. Therefore, r prime t is equal to 1 over square root of 1 minus 1 over t the whole square. Multiply that by the derivative of 1 over t, which is negative 1 over t square. So that is equal to negative 1 over square root of 1 minus t square times 1 over t square. That is equal to negative 1 over square root of t square minus 1 over t square multiplied by t square. So that is square root of t square is a t, and this goes to the numerator because it's the denominator of the denominator. So it goes to the numerator, t goes to the numerator, square root of t square minus 1, and t square stays there, 1 t cancels. So the final answer is negative 1 over t times square root of t square minus 1. Number 28. Y is equal to cos inverse sin inverse t, a really complicated expression. So dy over dx is negative 1 over square root of 1 minus sin inverse t the whole square times derivative of sin inverse t, that is 1 over square root of 1 minus t square. So that's all. You have a negative 1 over square root of 1 minus t square minus times square root of 1 minus sin inverse t the whole square. Just application of the formula. Next, number 38. Y is equal to tan inverse x minus square root of 1 plus x square. Tan inverse x minus square root of 1 plus x square. Again, it is a chain rule. So that is going to be 1 divided by 1 plus the argument, this is called the argument square, multiplied by the derivative of this part. So that is 1 minus 1 over 2 times square root of 1 plus x square times 2x. 2 cancels. And a simplification is possible. You FOIL this. When you FOIL, you get 1 plus x square minus 2x times square root of 1 plus x square plus 1 plus x square. And then here you can make them upon a common denominator. So it becomes square root of 1 plus x square minus x divided by square root of 1 plus x square. You express that in a common denominator. So that is equal to x square cancels, 2 minus 2x times square root of 1 plus x square times square root of 1 plus x square minus x divided by square root of 1 plus x square. Yeah, so that is it. See, the calculus part is not difficult, but the algebra is a little difficult in this case. Okay, next is number 36. Number 36 is fx is equal to sine inverse e to the x. So f prime x is equal to formula for sine inverse 1 over square root of 1 minus x square. So in this case, square root of 1 minus e to the x the whole square. Now you have to differentiate e to the x. That is derivative of e to the x is e to the x. That is equal to e to the x over square root of 1 minus 2x. And now number 44, cos inverse 1 plus x square over 1 plus 2x square. So the calculus is a little difficult here. That is limit x approaches infinity. It is no differentiation. Limit x approaches infinity, cos inverse 1 plus x square over 1 plus 2x square. You divide all the terms here in numerator and denominator by x square. So you get limit x approaches 0, cos inverse 1 over x square. You are dividing each term by x square. 1 over x square plus x square over x square divided by 1 over x square plus 2x square x square. So x square cancels here. That is equal to limit x approaches infinity, cos inverse 1 over x square plus 1 divided by 1 over x square plus 2. When x is infinity, 1 over x square is 1 over infinity, which is 0. So these two terms are 0. You get cos inverse 1 half, and cos inverse 1 half is pi over 3. Okay, that's the end of the second part, and we have one more part that I will post later.